Hi, this is Alex from devstories.eu. GeoDjango and PostGIS, Episode 3 of 15. Turning your standard database into a spatial engine takes exactly 3 words of SQL, but if you execute them in the wrong context, your Django application will fail on its very first migration. Today, we are focusing entirely on setting up your spatial environment. We start at the database layer. You already have PostGRE SQL running, and you have created an empty database for your new project. At this stage, that database is completely standard. It only understands text, integers, dates, and standard relational types. It has no concept of what a coordinate or a geographic boundary is. To change that, you need to enable PostGIS. People often trip up here by assuming that installing the PostGIS packages on their server automatically makes every database spatially aware. That is not the case. The spatial extension must be created inside the specific database your project will use. You must connect directly to that new database using a database client or the command line. Once connected, you execute the command to create the extension named PostGIS. Those 3 SQL words instantly transform the environment. PostGRE SQL executes the command, loading hundreds of spatial functions and specialized data types into your schema. It also generates a crucial system table that stores the spatial reference systems, which provide the mathematical formulas required to project global coordinates onto a flat screen. With the database prepared, you shift over to your Django project. You bootstrap a standard project and create a new application. Let us call this app World. Now open your settings file. There are 2 distinct modifications required to bridge Django and PostGIS. First, locate your installed apps array. You need to add the module named django.contrib.gis. This module is the core of GeoDjango. It loads the Python wrappers for the underlying geographic libraries, providing the spatial fields and geographic database lookups you will use to write queries later. You also append your new World app to this list, so Django knows to track its models. Here's the key insight. The second modification happens in your database configuration dictionary. Django routes all database traffic through an engine backend. If you leave the engine set to the default PostGRE SQL backend, Django will treat your spatial database like a standard relational database. It will not know how to serialize a geographic shape or safely parse a bounding box query. You must explicitly point the engine to the GeoDjango PostGIS backend. You change the engine value to django.contrib.gis.db.backends.postgis. The rest of the connection dictionary remains identical. You still provide the database name, user, password, host, and port exactly as you would for a standard setup. When you run your initial migrations, this new backend takes over. It connects to PostGRE SQL and immediately checks for the PostGIS extension. If you forgot to create the extension in the database, the backend will catch the missing spatial types and throw an error. If the extension is present, the connection succeeds. You now have a complete spatial pipeline. The true power of this specific configuration is that once the PostGIS backend is wired up, the massive complexity of spatial database queries is entirely hidden behind the familiar Django object relational mapper. That's all for this one. Thanks for listening, and keep building.